Well, good evening, everyone. It is March 1st. Welcome to the Recharging Chat 2023. I'm Sharon Kimberly Cravens here with Dr. LuAnn I, and tonight we're going to talk about the lovely slimy subject that is biofilm. Before CellCore, I had never really knew what biofilm was. I'd heard of it, but now I've fallen down the rabbit hole, and there's so much to know and learn about biofilm. It's on stones in streams. It's on anything that's damp, moist. It's in the body. It's on teeth. A good example is plaque on your teeth. The most common biofilm interrupter and remover everyone has in their home, right? You wake up in the morning, you have the slime, biofilm. So tonight we're going to chat about where they come from, how they're disruptive to our systems, and how CellCore is assisting with removal of them from our bodies. Sound exciting? So another example of biofilm, which is why I think I can't stand it, kombucha, right? Slimy. Like it's the yeast creating its barrier. And there's just something about my innate intelligence that says, I don't want to drink that. Like I know people love it, but so that's just my 2 cents on that topic. Water in your pet's bowls. You know, you give them some fresh water and then a day passes or maybe even a couple hours, and then it's got that weird slime and it takes some time to remove it. It takes like scrubbing to remove it. You can't just dump it and refill it. It's still there. That is biofilm. I have a really interesting photo I'd like to share of how biofilm can enter the body. So this is outside of actual parasitic type infections. This is medically. So you go in to get a procedure, you have a shunt or a port or something that's invasive into the body or even dental. And just to show you some avenues of how biofilm can develop, I thought I'd bring that here. So there's the Vitruvian Man, Da Vinci in the middle. Up here we have sinusitis, there's a breast implant, stents, urinary vascular stents, catheters, even joint replacement, cochlear implant, you have a burn. There's a lot of different avenues and pathways, the most common being you go into a hospital, you get an IV. Depending on the type of bacteria, it can develop, biofilm can develop within, even 30 minutes. So just to kind of put that out there visually so that you can see, this is more medically oriented, but this is a natural way that bacteria will replicate itself when it comes in contact with the human body. So hopefully that stays in your mind. As far as what we can do about that once it does enter the body, we'll get into that a little bit later. So I just wanted to share that to begin with. And then we have a document that we're going to pull up and I'll share that. The most important things to know about biofilm. So, Dr. Lu, you want to begin?
Yep. So from the, oh, that's very small. So from just from what Sharon was saying and that picture that she had up about the different ways that we see biofilm enter or when you're in the hospital setting, a lot of people you hear, they go into the hospital and then they come home and they get some kind of infection. And that is the biofilm that's creating these infections in the body. So we're going to go into it from our perspective and from the cleaning that we're all doing. But it is important to mention these because it's not just something that we run into when we're doing the parasite and detox, but they could be very deadly. They could create very chronic and deadly diseases. And there's in the world of medicine, they have a lot of trouble controlling these, and there's constant research going on of how to break them down, how to stop these communities from growing and causing infections in people that they are doing different surgeries on. So what we're going to talk about tonight, though, is we're going to understand the basics of biofilm and how we're getting it out of our bodies to better ourselves. So as Sharon mentioned before, the plaque on our teeth, the layers in our gut lumen, all have different levels of biofilm. They're everywhere in our environment. Like she was saying, you see it in the pond, you see it in your pet bowl, and they are a threat to our health. According to the National Institute of Health, more than 65% of the microbial and chronic infections are associated with biofilm formations. So if you run your tongue along your teeth, after a long day, you feel that slimy coating you're noticing is an oral biofilm. Found everywhere in nature, biofilms form where bacteria stick to the surface in moist environments. Bacteria do this by excreting a slimy, sticky substance, and unsurprisingly, the kind of biofilm you get depends on the kind of bacteria making it. So the body has 5 major sites of the biofilms: the gut, the mouth, the respiratory tract, the skin, and the genitourinary tract. And these communities are commonly referred to as the microbiome. So a lot of you that have been using CellCore and working with me have heard me say, oh, it's a biofilm. Oh, we got to open the biofilm. Biofilm, it hides everything. The biofilm is created by the parasites, and they're hiding inside of it. So tonight we're going to get into this a little bit deeper, because a lot of the issues that people have are caused by these biofilms because they're hiding the agents inside of them. So Sharon, want to put that up a little bit?
Sure.
Thank you. I'm going to just skim through this a little bit. So this guy in Natural Medicine and Journal, Jacob, he explained them as certain microorganisms, in particular certain species of bacteria and yeast, will convert or coalesce from individual free-living single individuals into an aggregate of cells. These aggregates are bound tightly together by a film of secreted material, a hydrated polymetric matrix of their own synthesis to form biofilms, best described as slime. Thus, bacteria and some yeast can exist in 2 different life forms. In one form, the individual bacteria exists as a single independent or planktonic cell. And in the second form, the bacteria organizes into sessile aggregates. So what this means is that biofilms are groups of organisms, including bacteria, viruses, fungus, parasites, and they form these communities around I wrote damaged and infected areas of the body, but it's not just damaged or infected areas. As we talked about earlier, we talked about the teeth and all these different things. So if you have one little bacteria or microorganism, it will signal to other microorganisms in the body. And we're going to get into this a little bit later, but they all want to come and gather together and create this polymetric matrix, or this slime that they start to secrete as they gather together. And we're going to describe a little later how they talk to each other to create this gathering and create this this slime that's very hard to get rid of and very hard to break down. They're notorious for forming on implanted metal devices, like Sharon showed us earlier, plastics, catheters. There's biofilm infections, and they affect millions of people in the developed world. These include pneumonia and cystic fibrosis patients, because cystic fibrosis and with the lungs and MS, with a lot of things that happen, they're very similar patterns of things that happen from the biofilm and from parasites. So when these different ear infections and sinusitis and implants, they get this biofilm on it, and this is resistant to treatment. Most of what the medical community treats with is an antibiotic, but because of these single-celled bacteria or planktonic forms are getting together with other ones, and they're creating this big microorganism of this slime, they become resistant to the antibiotic, and it can't get into through the slime to get to them. So they develop this colony that becomes resistant, and it affects us in many other ways. So you just think about, if you take a like a cotton ball, or you take the what's that called when it's inside a chair, the stuff that they stuff it with. I think you know what I'm talking about. It's like very thick cotton, and it has all these little nooks and crannies in it. And if you imagine having that and taking sand and throwing sand into it, and now you want to get the sand out of there. That cotton that I'm describing, that's the biofilm, and all the sand that's in there, that's the microorganisms and the parasites and all of these critters that we're trying to get out of the body, that are creating this biofilm and hiding inside of it. So that matrix that they create, that they secrete, is really hard for us to get through and to get these critters out of. Does that make sense to everybody? Can you visualize that more now? Okay.
Can I just add also that it's just like it says, bacteria and some yeast can exist in two different life forms. So literally, they create their own matrix, and it is like the matrix movie, because they have two different lives. So just like in the movie, there was like a world within a world. It just reminds me of that, literally. So I just wanted to add that. To carry on with this, in simple terms, biofilms are a group of organisms, including bacteria, viruses, fungi, and parasites, that form a community around, like she said, damaged, infected areas of the body. They adhere to a substrate or matrix that is not necessarily alive or even organic. So I was listening to a video earlier about food prep and keeping the kitchen super clean, so that biofilms weren't created by, slime from food. So some of the examples were lettuce on stainless steel. It'll grow. It doesn't matter. It doesn't have to be an alive or organic item or material. Biofilms are notorious for forming on implanted medical devices made from inert plastics, such as indwelling catheters. Biofilm infections affect millions of people. I'm sorry, I'm reading what you already read, LuAnn. Sorry. Never mind. How biofilm is made. Microorganisms tend to move freely about as single cells, referred to as planktonic. These individual microorganisms may then attach to a surface, such as the GI tract, clump together into a matrix form, and then develop a colony. Biofilm itself is a densely packed colony of microorganisms enclosed in a secreted extracellular polymeric substance matrix. So that's EPS. Yay. What's happening? EPS. Okay, I'm having issues here. Sorry, guys.
It's okay. No worries. So,
Tripping out. Okay, maybe we go into, oh, this matrix is like a slimy layer and acts as a glue. It also forms a physical barrier around the colonizing microorganism. In simple words, EPS is a protective shield which the microbes use to protect themselves from your immune system. The shield also hides the microorganisms, making it hard to detect them in lab tests, and then they're difficult to address. Within this matrix, the microorganisms operate as a coordinated group similar to multicellular organisms. Larger colonies may have various species of microorganisms within their very complex structures. They thrive more effectively than if they were living on their own. Furthermore, the protective shield makes the microorganism resistant to antibiotics and medications, which makes the infections chronic. So that is a huge point right there. In these biofilm communities, anaerobic bacteria can attach to inert surfaces, but then they facilitate the development of an environment in which aerobic bacteria can form. And it gets even more complicated as these diverse organisms can then start exchanging genetic material. So it gets more involved. Then how do they communicate? So these different bacteria, viruses, they don't necessarily have eyes and ears. So how do they communicate? You want to talk about the quorum sensing, LuAnn?
yes, quorum sensing is very cool. I don't know if you could pull that cute little picture up after I'm done reading through this, but just so they can get an idea. So, this is pretty new in this whole scheme of things of recognizing this, but so they have you, like I was saying earlier, you have a single cell bacterium and it wants to kind of look around its environment and it senses how many other bacteria are close in close proximity to it. And if it can sense that it's surrounded by a dense population of other pathogens, it's going to want to join them and contribute to the formation of a biofilm. Bacteria that's engaged in quorum sensing, they communicate by emitting chemical messengers that follow instructions. They follow infectious agents they could recognize. So when the messages grow strong enough, the bacteria respond and massa, which means a message, they behave as a group. So quorum sensing can occur within a single bacteria species or between different species and can regulate a host of different processes, serving as a simple communication network. A variety of different molecules can be used as signals. So you can have this bacteria sitting, let's just take, for instance, a tool that gets sterilized or something that's sterilized, and then you're going to put it in the body. If there's one little piece of bacteria on it, that bacteria is going to use this form of communication. It's going to send out some kind of sensor to see, are there bacteria in this region anywhere? And they're going to communicate and they're going to kind of find each other. And then they're going to start to emit, they just send out these chemicals that form this sludge. But when they're in there, they start to communicate with other bacteria or other microorganisms. Like this is how a lot of like the co-infections from Lyme really love to hide inside of this, and they live inside there and they have a party, and that's why it's very hard to get that stuff to come out of the body because it's hiding in here. And so when we are clearing the gut and we're removing parasites and we run into dysbiosis in the gut, where we're having different issues with diarrhea and constipation and bloating, and there's all kinds of different types of bacteria and microorganisms that are hiding inside of this biofilm. And this stuff is locked into our system. It could be anywhere, but I mean, primarily we deal with the microbiome, which you learned earlier is very large. People just usually associate it with the gut, but as you see, it's all over the body. So when we're breaking up this biofilm, and we're breaking these communities up that formed, that created the biofilm. And so through this quorum sensing, they're going to continue to try to survive and try to communicate. So not only is it stuff that creates in the body and makes the gut like resistant to antibiotics, which we hear so much about, all that stuff, but it also creates this safe haven for the parasites, for the different little fungus and different microorganisms to hide inside that make us very sick. Yeah, that's a cute picture.
Here's the creepies. They're texting each other. Carbs are great, says, let's eat here. And Matrix Lover says, should we stick together? So that's cute.
Yeah, so that's a simple diagram. So you can get a visualization in your head, but picture these little guys. There's one and they hear a message from another one and they start to group together. And before you know it, they're forming these colonies. But what they can also do is once they start to form these colonies, a piece of that colony now that it's strong enough, it can break off and then go somewhere else in the body and start forming another colony. So as we're going through this whole protocol, we're breaking up a lot of this, and it could be in our ears, it could be in our sinuses, in our throats, in our lungs, in our gut. And as it starts to break apart, that's one of the reasons why I'm always asking, are you taking your binders? Are you taking your binders? Because that stuff needs to be bound up with the binders to pull it out of the body, so it's not recirculating and creating more issues, because it's toxic. It's what's in there is locked up toxins.
Great. Okay. So persisters, when bacteria become involved in a biofilm, their usual behavior changes. A prime example of this is that the bacteria rarely divide or reproduce. This is part of the reason biofilms are so resistant to standard antibiotic therapies. In fact, depending on the organism and type of antimicrobial and experimental system, biofilm bacteria can be up to 1,000 times more resistant to antimicrobial stress than free-swimming bacteria of the same species. So even a heavy course of antibiotics, even if a heavy course of antibiotics is successful, I'm sorry, I'm having issues. Several cells called persisters are left behind that remain alive and viable and can then start the process of division and repopulation. This is yet another survival mechanism that biofilms employ. Though biofilms are essential for the growth and survival of healthy flora, unfriendly bugs can also use these structures to repopulate and are the root of many long-term, recurrent, and reluctant infections. If you hear or utter the phrase, I get better for a while and then all my symptoms come back, think biofilm issues. No number of antimicrobial agents, pharmaceutical or herbal, properly address these issues. Well, I wonder about that. You must break down the structure of these biofilms so the antimicrobial agents can do their best work. So with CellCore, that's what we're doing. We're doing herbals. So would you take issue with that point, LuAnn?
Well, this is in general statement. We are doing herbals, but there are some, and some of the stuff that we use that is known to break down the biofilm. And some of the stuff like CT-zyme is the proteolytic action of that is made, and it breaks down the biofilm in our system. So there have been things in the past on the market that were say, this is not going to work, this is not going to break down the biofilm, but the stuff that we use, we see it does break down biofilm.
Okay, thank you for answering that. Biofilms and Lyme disease. I can't make this large, so I'm not going to do
That's
that.
great right there. That's great like that.
Lyme spirochetes tend to hide out in biofilms, which remain dormant. This helps explain why antibiotics can be ineffective once the biofilm starts to develop, and why it is important to treat Lyme infections aggressive early on. As mentioned above, biofilms are also a significant issue for implanted medical devices, such as prosthetic joints, mechanical heart valves, IUDs, catheters, etc. And what makes diagnosis of biofilm challenging? There are several reasons why lab tests often fail to detect this colony of pathogens in your body, and there's several reasons. Namely, it acts as a protective shield. So the pathogens are enclosed in a slimy protective matrix shield. This means that cultures and swabs often show negative results. Stool tests may also prove inconclusive, as the samples do not contain any of these pathogens themselves. Accurate procedures are unavailable. It is difficult to obtain microbial film samples from some areas of the body. For example, it's hard to get samples from the actual GI tract, as this would be incredibly invasive, like an endoscopy. Present procedures would also fail in removing the colonized bacteria, which is hidden in the slimy layer of the GI tract. It just wouldn't be accessible. They're not easily cultured. Pathogens from these films are not easily cultured. The obtained sample might test negative, as the microbes can adapt to lower nutrient requirements. They're quite clever. I don't know if that is necessarily pleomorphism, but they have their own intelligence. So do you want to go over the stages of development, or you want to just get past this?
Let's go past it.
Okay.
Because we have a lot to cover.
Do physical reactions, biofilm infections.
Yeah. Okay. So when the colonies of the pathogens grow in your body, they can trigger stress. So neuroendometabolic, NEM, stress response system helps your body to deal with the stress. So as an intricate network of various organs and circuits. So there's the inflammation circuit that functions in close coordination with your adrenal glands to help your body deal with stress. The adrenal glands look right, they sit on top of your kidneys. They produce anti-stress hormone called cortisol, and it's part of that response system. So when you experience stressful conditions, the NEM signals your adrenal glands through the hypothalamus, pituitary adrenal axis, and it secretes cortisol to deal with the stress. However, when the stress persists, the adrenal glands are forced to secrete more cortisol. This excretes additional pressure and overburdens them. Therefore, the adrenal glands are no longer able to secrete adequate cortisol. And this reduces the natural stress fighting ability, and it can lead to adrenal fatigue. So this adrenal fatigue syndrome, everybody's heard of that. When you experience a lot of stress over time, you also have other symptoms that go with it, including anxiety, brain fog, insomnia, low energy levels, difficulty in waking up, low concentration levels, stubborn weight gain, and craving for fatty and salty food. Now, there's a lot of other things tied into the adrenal fatigue syndrome. And, if you just go in and you treat adrenal fatigue and you take something for that, again, just like we had explained another time, it's like starting in the middle of the alphabet and not starting it from the beginning, because that's really just a symptom that occurs from all these other things that are really causing the problem. So the inflammation circuit comprises the gut, the microbiome, the immune system, and any imbalance in the circuit can lead to food and chemical sensitivities, recurrent illnesses, and prolonged healing periods, leaky gut, musculoskeletal pain, exacerbation of autoimmune disorders, and yeast infections. I don't like using the term autoimmune disorder because autoimmune is something that I feel greatly about. In the future, we will realize that there really aren't autoimmune, because our body's not going to go turn around and start turning on itself. And I feel like we'll be learning more about that in the future. We already know a lot about it, but that is my opinion and not the medical opinion. They still call them autoimmune diseases. So common infections related to biofilm are found almost everywhere. Many significantly impact the human health in both positive and negative aspects. So Staphylococcus epidermis bacteria provide a positive effect by impeding the colonization of potentially pathogenic bacteria. This is done through stimulation of the host cell, immune defense, and prevention of adhesion. The microbial colonies enclosed in a slimy layer are also associated with several plant infections and pathogenic form of human disease. So when the pathogen colonizes and starts to form a film, it gets harder to detect and eliminate. This is especially the case in the longer the pathogen is present. The slimy film shields the pathogen from your immune system, as well as accelerates the growth and dispersion of the microorganisms throughout your body. The film also provides a favorable environment for new pathogens to attach and grow. This paves a path for the development of various diseases within your body. It is very interesting to know that many diseases and chronic health issues go unresolved for years due to similar undetected infections. There are probably several health conditions which people continue to suffer from for decades: yeast, bacterial, parasitic infections, particularly with a history of treatment resistance. Then it can indicate a biofilm infection. So we're going to skip over cystic fibrosis, but I just want to nutshell what I was just reading. So what it's saying again, because we have biofilm formation in our body, and it can happen, starts right away when we're young, it starts to happen. But when it gets out of control, as we're taking things like antibiotics, and it starts creating more issues in our gut, and different things like co-infections from Lyme that were introduced into our body through mosquito bites and ticks and all different types of transmission. It's not just from ticks, but like we talked about on our other class, and different types of worms and things that enter that are hatched from eggs. When these biofilms form around them and protect them, they can also spread to other areas of our body. So if it can be in our gut, but then it could move into our lung, it could move up into our sinuses and ear, can get into the central nervous system. Like that's why when we have a lot of some co-infections of Lyme and some of these parasitic conditions that get into the brain, they're hard to get out because these things have been hiding in the biofilm for so long that we have to break all of this down. And like we had mentioned when Sharon was reading, people often say, well, can I take a test to see if I have it? Can I take a test to see if I have it? You can take as many tests as you want, but it's not going to show you a lot of this stuff because it's not going to detect what's hidden in the biofilm. And that's what we know. And, you often hear, well, why there's a lot of medical doctors that will not recognize a parasitic infection. will not recognize this stuff. They understand biofilm. They see it all the time when they're doing, that's why they have to be so careful in their surgeries and stuff. But when you're dealing with stuff like this, that's hidden from the body's immune system, and then you go in and you try to do a swab, or you try to do blood work, or you try to do different types of labs to try to detect it, it's not detectable. It does become detectable as we start to bust the stuff out, and it's circulating in the bloodstream at that time, and we do a blood test for something, then we might be able to see it. But there's not like a lot of tests that are going to be accurate with a lot of the stuff that we are setting free, so to speak, and getting out of the body.
All right, so some of the common infections related to this category: cystic fibrosis, upper respiratory tract infection. Despite several barriers, the upper respiratory tract is easily breached by pathogens. Therefore, the ear, nose, and throat are highly vulnerable to acute and chronic infections, which we know. But it's saying bacterial colony mainly develops through the contamination originating from the use of artificial medical devices such as catheters and valves, urinary tract infection, that can invade the renal tissue, can cause kidney inflammation, swollen prostate, stents and catheters, can cause infection. What else? Oh, women can experience recurrent UTIs despite their urinary tracts being physiologically and anatomically normal. So that's kind of a big deal. Dental plaque. Another example of biofilm in the human body is dental plaque and potential dental cavities, consuming of fizzy carbohydrates, which nobody drinks here, right? Such as sugary drinks or treats, encourage dental plaque bacteria to secrete organic acids. When this is left untreated, the increased acidification by the film can lead to demineralization of the enamel and create dental cavities. The dental plaque biofilm can cause periodontal disease, which nobody wants. GI disorders. Basically, this is saying that biofilm microorganisms are responsible for over 80% of GI infections in humans. So that's pretty telling. Because of its viscoelastic mucus lining, the GI tract has that for protection. It can be damaged, excessively inflamed, and it's got, because of that, when the microbiome is damaged, there's an opportunity for microorganisms to attach to the surface and unload the slimy biofilm. And then there's pathogens that invade, et cetera, et cetera, et cetera. That can affect adrenal fatigue and create all kinds of other issues. And it's also why in most cases antibiotics and medication fails to correct things like IBD, Crohn's disease, and ulcerative colitis. Even though medication can work for a little while, a person can have flare-ups. Lyme disease, it's saying that most people that have been infected will have prolonged symptoms due to the presence of this film, and they'll have antibiotic resistance. Biofilm's really hard to get rid of. It becomes increasingly tolerant and also resistant to certain antibiotics. So that is one of the takeaways after I was doing more research on this. So it's saying the condition is difficult to diagnose because it mimics other disorders, right? So it's got its own intelligence, never mind the biofilm. And the biofilm allows the Lyme to thrive. So some other conditions related to biofilm: pneumonia, Epstein-Barr, recurrent tonsillitis, and chronic cystitis, sinusitis, prostatitis, dysbiosis, recurrent otitis media, bronchiectasis, can't even say that, prosthetic failure, kidney stones, osteomyelitis, cystic fibrosis, and again, periodontal disease. So, as we all know, the traditional approach involves throw antibiotics at it, right? Research shows that these drugs do not help eradicate the pathogens. In fact, antibiotics have been shown to contribute and to fuel the condition. So, they're suggesting 3 steps to break down and remove the biofilm. Break it down, destroy the pathogens, and eradicate the leftover matrix, minerals, and DNA from your body. How do you want to wrap that up, LuAnn?
So basically what they're getting into now is kind of what I had just went over about labs that, you can't detect the stuff because the lab work can't get what's inside the biofilm. And so what we do is we use stuff to break down the biofilm. And some of the other stuff we use gets rid of the pathogens. And then we rebuild the body. So what we are using mostly, I'm going to start wrapping it up here because we're getting to our time limit, Sharon. So
Yeah.
I'm going to start going, if you want to just scroll to the end of this, I'm going to start going over some of this. Biofilm, like we said, we house toxins and heavy metals, and it stops absorption of stuff through the intestines. It creates inflammation. Basically everything that we talk about all the time, right? So you have parasites, you have yeast, you have bacteria, you have all of these things that hide inside biofilm, and they're all protected by this biofilm. So a lot of things that people have, like chronic fatigue, fibromyalgia, GERD, and irritable bowel syndrome, colitis, Crohn's, parasites, SIBO, heartburn, bloating, gas, abdominal cramping, brain fog, arthritis, acne, skin conditions, candida overgrowth. A lot of these are from the biofilm allowing all this stuff to just grow and thrive and not be detected or touched. So when we go through the CellCore process and we start to, the first thing we work on is opening up drainage pathways. And as we open up the drainage pathways, we start to prepare to break the biofilm down and pull it out of the body. So some of the products that we use have like Para 2. Para 2 has neem in it. Neem is a big it's a big biofilm buster. So as you're going through this and you see stuff leaving your body and you see it in the toilet and it looks kind of slimy and it looks kind of gross and watery and people experience different things, what you're witnessing is your body is removing a lot of the biofilm. So a few of the things we use is Para 3 is a big biofilm buster. CT-zyme is a huge biofilm buster. It's a proteolytic enzyme. When we take it away from food, we take it separate from food, it's going to work to break down this biofilm. The Para 2, again, another biofilm buster. CT minerals, all of this stuff is helping to constantly assist your body in breaking these down. What's important to remember is you always want to be on a binder, because the binders are going to pull this stuff together and eliminate it through your bowels, because you don't want this, as we're releasing these parasites and these microorganisms and these little tiny creatures, we don't want this stuff to recirculate. So we stay on the binders and we pull it out. And then we have all of the support. We have the Lymphactive, we have the KL support, we have the kidney and liver support, which are you can use those at any time, and those are going to support all of your drainage organs. And as your body's healing and you're removing all this, you're strengthening those organs by giving them these supports. So you always hear us say there's a systematic way of doing this, where you don't just go in and go, oh, you have a problem with your leaky gut, or you have leaky heart, or you have brain fog, or you have Lyme. We don't just go in. The traditional way is, in functional medicine, they'll go straight to it and they'll start working on that without preparing the body. So again, this is very foundational with CellCore. We do everything in a specific order so we can go in and allow for the gut to be fixed, allow for the for appropriate timing for stuff to be removed from the body, not too early in the game. Not go in, and if somebody has Lyme and we know it, we're not going to go in and treat them and say, okay, we got to kill this aggressively. We're going to go in and bombard you with antibiotics. The reason that is so bad is because now their body's immune system is already shot. So now you're going to make it worse. And now you're going to lead them into chronic Lyme issues. Instead of going in, what we do in CellCore is we address Lyme, but it doesn't come in until later on, because systematically, if you take care of all these other steps, you're going to be able to increase the body's immune system naturally. So the body can take care of the Lyme and the co-infections by pulling out all of this, all of the different parasites, pulling out all of the biofilms that are hiding a lot of the stuff. And the way that everything is created in CellCore with the carbon technology, we are repairing things at the same time with all the carbon and the hydrogen and the oxygen, and that technology that has the ability to share a proton or share an electron, or remove something that doesn't belong there and then donate something that it needs. Not just going in there and pulling things apart, but it's repairing stuff. So I hope you learned a lot about biofilm tonight. And so when you see this stuff come out in your toilet and you go, oh my God, what is this watery stuff? Or what is this slime? Or, oh, I'm feeling like I don't know what I'm feeling. My stomach feels very strange. It might be biofilm that's being released. And you remember, okay, I'm going to use my binder. Maybe I need to use a little bit more binder to help bind it and pull it out of my body. And, giving yourself adequate rest while you're doing this. 8 hours minimum of sleep to allow your body to repair. These parasites, they're hidden in all of that stuff, and they can, when they're starting to be pulled out, they can really start fighting back. So they don't want to leave. They love living inside of us.
Yeah, let's show the video of the pair of 3 here.
Okay.
Pair of 3 on this. I'll do it on this other end. Hello. Boy, it's making some bubbles. Let's also start to break this up. Look at that. It's not nearly as, oh my goodness. These little black flecks are the charcoal experiment that I did. But this pair of 3 is totally breaking up the biofilm. Hello.
It's pretty cool. So that was taken from where, LuAnn?
It was just a friend of a friend who did an experiment and shared it, and who on her own biofilm. Okay,
Cool.
so we'll stop the recording now, and then I forgot to mention, if anyone had any questions, you can put them in the chat and I will, Sharon or myself will respond. Or if there's anything pressing that somebody has a question about right now, you can go ahead and ask. Just stop the recording first.
Yeah, I just want to say our next call is going to be on March 15th. So the Ides of March are coming before we go to Costa Rica. And that call is going to be on parasites and how they really break down systems in the body. So more specifically about, how they're so detrimental and how they affect the body in a grander sense. The full moon protocol begins, let's see, the full moon's on Tuesday. It's the full worm moon. So that's the 7th. If you're doing a 7-day, start on Saturday, which is the 4th. If you're doing a 5-day intermediate, start on Sunday the 5th. If you're doing a 3-day beginner, start on Monday the 6th. And Karen would like to know what to expect with each phase, so I know what to look for, some of the common symptoms.
Sharon, you want to stop the recording?
Yeah, good request. It's a good request though. What to expect with each phase.
Yeah. Yes, what to
No.
expect.
Hi, Karen.
Sorry, I had that make